So, something just happened with Starship that nobody expected. Not even the hardcore space fans who've been following SpaceX for years. It's like the moment you think you've seen it all, boom, SpaceX drops a surprise that flips the script entirely. And no, we're not talking about some minor update or routine test. We're talking about a full-on switch that could reshape the entire Starship program. Elon Musk and his team have made a bold move, possibly one of their boldest yet. It's not just a new plan, it's a whole new engine, and not just any engine. This one might finally solve the problems that have been holding Starship back for years. If you've been keeping up, you know that Starship's development hasn't exactly been smooth sailing. From overheating engines to explosions mid-flight, the journey has been wild. Every time we think they've nailed it, something else breaks. It's been like trying to tame a beast that refuses to be controlled. But now, out of nowhere, we get this surprise update. And it's not a tweak. It's a major shift that could be the answer to everything. Imagine going from a shaky, unpredictable rocket to one that could finally deliver on the dream: deep space travel, Mars missions, lunar landings, all of it. This change could make that vision real. Now here's the twist. The surprise isn't even about some future plan. It's already happening. A new engine has been spotted being moved to the McGregor test facility. You know what that means. SpaceX doesn't just move engines around for fun. When something shows up at McGregor, it's go time. And this engine, believed to be the long-rumored Raptor 3, is different from everything we've seen so far. It's sleeker, stronger, and designed with one goal in mind: fix every single problem that plagued Raptor 2. And we're not just making guesses here. Elon Musk has already hinted at some huge upgrades, and now we're starting to see those upgrades in the real world. The thing with Raptor 2 is that, while it was a big step up from the original Raptor, it still had flaws, serious ones. Cooling issues, resonance problems, component failures, you name it. These engines operate in brutal conditions. Temperatures in the combustion chamber can hit 3,000 degrees Celsius. Pressure levels are insane. One tiny flaw and it's game over. And during multiple test flights, Raptor 2 engines showed signs of stress. Some couldn't finish the burn. Some had to be shut down early. Others literally exploded. That's not sustainable, especially when your goal is to land humans on another planet. Clearly, something had to change. Enter Raptor 3. This isn't just a refined version of Raptor 2, it's a total overhaul. The changes go deep, right down to the structure and flow dynamics. And the goal? Make the engine more efficient, more stable, and more powerful, all while making it easier to build and maintain. From what we've seen and heard, this engine does all that and more. And it's not just speculation. Engineers at SpaceX have confirmed many of these changes publicly. So this isn't a rumor mill, it's real. Raptor 3 could be the final piece of the puzzle. The part that turns Starship from an experimental prototype into a real, operational launch system. To understand how big this is, you need to get what makes the Raptor engine so special. Unlike most rocket engines which use simpler combustion cycles, the Raptor series uses something called a full-flow staged combustion cycle. That's a mouthful, but here's the gist. It's one of the most efficient and powerful engine types ever designed. Instead of mixing all the fuel and oxidizer in a single chamber, full-flow engines send each component through its own preburner and turbine. That creates two high-pressure gas streams, one rich in fuel, the other rich in oxygen. These then merge in the main combustion chamber and ignite. This design has some huge advantages. For starters, it boosts efficiency. The more of your fuel you can convert into thrust, the better. It also allows the engine to run cooler in some areas, which reduces wear and tear. But it's also incredibly complex. Managing two separate preburners, turbines, and gas flows isn't easy. That's why hardly any other space agency has ever attempted it. But SpaceX did. And now, with Raptor 3, they've taken it to another level. Every part has been tweaked, rethought, or replaced to make the system more reliable. They didn't just fix what was broken, they reinvented it. One of the biggest issues with Raptor 2 was cooling. Rocket engines get insanely hot. If the chamber walls can't be cooled properly, they melt. That's what happened in some earlier flights. The solution? Regenerative cooling. This method uses the fuel itself, supercold liquid methane, to cool the engine walls. The methane flows through tiny channels in the walls, absorbing heat before it reaches the combustion zone. Then, as a bonus, the preheated methane is used in combustion. It's a brilliant system, but it has to be done right. In Raptor 3, SpaceX reworked the entire cooling layout. Channels are more efficient, better placed, and cover more surface area. But they didn't stop there. Raptor 3 also adds something called film cooling. In this method, a thin layer of methane is sprayed inside the chamber, forming a protective film. This film shields critical parts of the engine, especially around the nozzle throat, from extreme heat. Together with regenerative cooling, film cooling creates a double barrier. That's the kind of innovation that can prevent catastrophic failures during a long burn. Especially for missions that require deep space maneuvers or precision landings, these systems are essential. And the fact that SpaceX was able to incorporate both shows just how much they've advanced their engine technology. Another key upgrade? The plumbing. In Raptor 2 there were a lot of exposed tubes, wires and joints. Great for maintenance, terrible for durability. Those parts are vulnerable to heat, vibration and impact. They're the first to break under stress. Raptor 3 gets rid of most of that. As Elon Musk confirmed, all the small plumbing and wiring has either been removed or built into the main structure. That's a huge deal. Fewer exposed components mean fewer points of failure. And it also means you don't need an external heat shield. The engine structure itself becomes part of the thermal protection system. That's efficiency on another level. And get this, SpaceX even ditched the bolts. Yep, all those bolted joints in Raptor 2? Gone. Replaced by welded connections. Why does that matter? Because bolts can loosen, leak, or fail under high stress. Welding, when done right, is stronger, lighter, and more reliable. It also reduces engine weight, simplifies manufacturing, and lowers costs. Of course, it can make repairs harder, since you can't just unbolt a part and swap it. But the trade-off is worth it, especially if it means the engine is more resilient during flight. It's like trading convenience for raw performance, and in spaceflight, performance wins every time. All of this translates into one thing: raw power. Raptor 3 is more powerful than its predecessor by a significant margin. It generates 280 tons of thrust at sea level. That's 21% more than Raptor 2's 230 tons. That extra push could be a game changer. More thrust means Starship can carry heavier payloads, travel farther, and complete more ambitious missions. And it's not just about muscle. Raptor 3 is also more efficient, with a specific impulse of 350 seconds. That's a big number in rocket science. It means more work gets done with the same amount of fuel. More bang for the buck, literally. Oh, and did we mention it's lighter too? Despite being more powerful and more complex, Raptor 3 actually weighs less than Raptor 2. Around 1,525 kilograms compared to 1,630 kilograms. That might not sound like much, but in rocket science, every kilogram counts. A lighter engine means a lighter rocket. And a lighter rocket means better fuel efficiency, higher altitude, and faster orbital speeds. It's a ripple effect that improves the entire system. And considering how many engines go into each Starship, 33 on the booster and 6 on the upper stage, that weight saving adds up fast. Put it all together and what you have is not just a better engine, it's a revolution. Raptor 3 isn't just a patch for Raptor 2. It's the engine that could finally unlock Starship's full potential. All the design issues that held back earlier versions? Addressed. All the weak points? Reinforced or replaced. It's a smarter, tougher, more capable engine built for the future. And based on what we're seeing, it's not some distant goal. It's already being tested, refined, and prepared for flight. This is real. This is now. And it could change everything. So, what does this mean for Starship's next flight? Well, chances are Raptor 3 won't be used in Flight 9. At least not yet. But the fact that it's already showing up at McGregor tells us something big is coming. SpaceX is clearly getting ready to integrate these engines into future flights. And when that happens, expect a huge jump in performance and reliability. Starship has always been ambitious. But now, with Raptor 3, it finally has the engine to match those ambitions. And that, more than anything, could be the key to making history. Raptor 2 engines faced a fair share of technical issues, especially during static fire tests and early flights. But now with the introduction of Raptor 3, things are taking a promising turn. SpaceX has clearly spent time and resources ironing out many of the bugs that plagued its predecessor. From the outside, it may look like just another engine, but internally, Raptor 3 is a major leap forward in terms of stability, performance, and engineering refinement. While Raptor 2 served as a testbed, Raptor 3 feels like a final product, built with lessons learned and designed to push the Starship program forward. Raptor 3 still uses the full-flow staged combustion cycle, which is one of the most efficient and complex rocket engine designs ever created. In this cycle, both liquid methane and liquid oxygen go through separate preburners and turbines before entering the combustion chamber. This allows the engine to operate with higher pressure and better efficiency. In Raptor 3's case, almost all of the liquid oxygen flows through an oxygen-rich preburner, and most of the methane flows through a fuel-rich one. Only small portions of each propellant cross over into the other stream, optimizing performance without compromising the combustion process. This system ensures that both propellants, methane and oxygen, are converted into high-pressure gas before they meet in the main combustion chamber. The actual ignition starts inside the pre-burners using torch igniters. These igniters are like miniature rocket engines that burn a mix of methane and oxygen to get the pre-burners going. Once they're lit, the high-pressure gases produced are then injected into the main chamber, where the final combustion takes place. This approach creates a controlled environment that reduces instability, which was one of the key problems Raptor 2 often experienced during prolonged operation. One of the biggest improvements in Raptor 3 is its advanced cooling system. Raptor 2 engines on Starship Block 2 struggled with extreme temperatures that reached up to 3,000 degrees Celsius. Without sufficient cooling, this kind of heat can deform pipes, crack walls, or even cause fuel leaks. Raptor 3 addresses this with regenerative cooling. Supercooled liquid methane is routed through internal channels inside the combustion chamber and nozzle walls. As it absorbs heat, it simultaneously cools the engine components and preheats the methane, making it more efficient during combustion. It's a smart design that improves safety while boosting performance. In addition to regenerative cooling, Raptor 3 incorporates film cooling, a technique where a thin layer of methane is sprayed along the inside of the combustion chamber. This methane film acts as a thermal barrier, particularly around vulnerable areas like the nozzle throat where temperatures are at their highest. This combination of regenerative and film cooling prevents dangerous hot spots and extends the engine's life. It also guards against potential failures like cracks or structural fatigue that were more common in earlier Raptor versions. These refinements are a direct response to the lessons SpaceX learned with Raptor 2. This isn't just speculation or guesswork. Elon Musk himself confirmed many of these improvements on X. He stated that Raptor 3 required all small plumbing and wiring to be either removed or integrated into the engine's main structure. That's because Raptor 3 will operate without a heat shield, meaning every part must be actively cooled in some way. To handle this, regenerative cooling was added even in places where there wasn't originally any fluid or gas flow. This shows how deeply SpaceX has rethought the engine layout, ensuring that every inch of Raptor 3 can survive extreme launch conditions. Another dramatic change in Raptor 3 is the complete elimination of bolted joints. In Raptor 2, bolts were used for easier assembly and maintenance, but they posed long-term risks. Under the stress of extreme heat and vibration, bolts could loosen, leak, or degrade over time. Raptor 3 solves this by replacing almost all bolted connections with welded joints. Welding increases strength, reduces complexity, and lowers the chance of fuel or oxidizer leaks. It also improves thermal resistance and makes the entire structure more resilient under flight conditions. It's a trade-off that sacrifices convenience for maximum durability and reliability. Switching to welded joints also reduces overall engine weight. Raptor 3 weighs about 1,525 kilograms compared to Raptor 2's 1,630 kilograms, despite being more powerful. It produces a staggering 280 tons of thrust at sea level, a 21% increase over the 230 tons generated by Raptor 2. On top of that, it has a specific impulse of 350 seconds, meaning it's more efficient in turning fuel into thrust. These numbers make Raptor 3 not just an upgrade, but a whole new class of engine. It delivers more power, better efficiency, and does so with fewer parts and less weight. These performance gains are made possible by bold redesigns across the board. SpaceX streamlined the engine by integrating many parts directly into the main structure, removing the need for external components. That means fewer points of failure and easier mass production. However, there's a small downside. Some parts are now buried under welds, which might make repairs or inspections more difficult. Still, the trade-off seems worth it. Raptor 3 isn't just built for testing or small-scale launches. It's clearly designed for reliability, endurance, and scaling to dozens or even hundreds of engines on future missions. In many ways, Raptor 3 feels like a patch for Raptor 2, a direct fix for all the issues that didn't work as expected. But unlike most patches that come with compromises, this one seems to have made things smoother, stronger, and more effective. And just like software, every patch is a step toward a more stable system. With the old problems now under control, phasing out Raptor 2 completely makes sense. It's the natural evolution. SpaceX now has a more mature engine design, and future upgrades will likely build on Raptor 3's architecture rather than starting over. And yes, it looks like we won't have to wait too long to see Raptor 3 in action. Just last month, A leaked image showed what appeared to be a Raptor 3 engine being transported to the McGregor test site in Texas. That's where SpaceX tests all its engines before integrating them into Starship or booster stages. Although it's unlikely that Raptor 3 will fly on the upcoming Flight 9, the company might already be preparing to install it in future missions. As testing ramps up, we'll probably see it installed and flying sooner than most people expect. Meanwhile, regarding Flight 9, there's already been some fast action. SpaceX replaced a Raptor Vacuum engine on Ship 25 after it failed during a recent static fire test. That replacement happened very quickly, showing just how efficient the team has become. But to make sure everything is running smoothly, another static fire test will likely be performed soon. This will be a full systems check, ensuring that the new engine operates correctly under stress. That second test could happen as early as next week, keeping the flight timeline on track depending on final FAA and company approvals. What's even more telling is that SpaceX has now issued official maritime warnings for the Indian Ocean, the expected landing zone for Booster 11. These warnings span the period between May 9th and May 22nd, giving us a solid launch window. Although a maritime warning doesn't guarantee a flight, it strongly indicates that SpaceX is actively planning a launch in that range. It's one of the best signs we get before any formal public announcement. This means the company is confident enough to notify nearby shipping vessels, which is one of the last steps before liftoff. Based on the current timeline and test schedules, the first half of the window, before May 15th, seems unlikely due to remaining preparations. But the second half of the window looks far more promising. If we look at typical lead times and internal test pacing, May 20th stands out as the most likely launch date. This gives SpaceX just enough time to complete testing, secure FAA clearance, and ready the ship and booster for integration and rollout. It would mark about 2 months since the last launch, which is slower than usual for SpaceX, but still within a manageable schedule. Remember, SpaceX's goal is to hit 25 Starship launches in 2025. So while 2 months between launches seems slow, the company is laying the groundwork for much faster launch cadences in the near future. One major enabler of this acceleration is Launch Pad B, which is expected to be fully operational by the end of the year. With a second pad available, SpaceX could conduct back-to-back Starship launches in the same week. That's a huge step toward meeting their ambitious goals and making Starship a truly reusable rapid launch system, just as Elon Musk has always envisioned. That wraps up today's update on Raptor 3 and the upcoming Flight 9 mission. The engine improvements, testing progress, and new launch window all point toward some exciting developments just around the corner. Thank you so much for watching, and we'll see you next time with even more updates from the world of spaceflight.